Deep in the mountains, engineers on the Donghu Mega Project have built a magnetic sled that tears through a concrete tunnel at 800 kilometers per hour. Launching this one-ton mass requires a violent surge of electricity. The power draw is roughly equivalent to a massive lightning strike. But there is a catch. The internal conditions of this frictionless empire are highly dangerous. If you walk inside wearing steel, the magnetic force alone becomes completely lethal. Massive concrete infrastructure is already breaking ground, moving the project beyond theoretical models into physical reality. To understand why a nation would spend billions constructing a transit system that is structurally hostile to human biology, we have to look at the extreme physics keeping the vehicle intact. Every standard train relies on friction, and that friction imposes a hard physical limit. If you push a traditional steel wheel past 500 kilometers per hour, it completely disintegrates into shrapnel. The engineering solution is magnetic levitation. This is the Shanghai Transrapid, a system that uses powerful magnets to float its cars above the track, touching absolutely nothing to eliminate mechanical drag. Scaling that frictionless technology to hit 800 kilometers per hour requires brutal physical labor. The foundation of this new project starts by driving 500 massive concrete piles deep into solid limestone bedrock. Standard steel tracks expand in the heat, which ruins the alignment. Engineers solve this by replacing the steel with carbon fiber tendons, locking extreme mechanical tension into every single concrete beam to prevent them from sagging. Above ground, the precision becomes microscopic. They balance heavy concrete pillars on top of titanium plates that are thinner than a single human hair. They take these extreme measures because at 800 kilometers per hour, being off by even a fraction of a millimeter is catastrophic. A tiny bump in the track acts like a solid brick wall, and the vehicle will explode on impact. Outrunning a commercial airliner on the ground means forcing absolute microscopic geometric perfection down into the solid earth. But even if the track is perfectly straight, the ground isn't the primary danger. At these speeds, the atmosphere itself compresses into a solid wall of air, generating enough pressure to instantly crush the vehicle. To defeat the atmosphere, they drop massive 12-ton concrete shields over the entire test track. Look at this cross-section diagram showing how the track is enclosed in a thick tube, with industrial pumps continuously sucking the internal air out. Working in tandem, massive industrial fans clear the entire tunnel of dangerous test debris in under 90 seconds flat. Creating this vacuum introduces a terrifying chemical danger. They rely on heavy vacuum epoxy to seal all microscopic gaps, because if a tiny pocket of air gets trapped under high electrical voltages, it instantly turns into deadly plasma. This structure functions as a heavily armored, completely artificial atmosphere engineered to cheat aerodynamic friction. Inside that vacuum tube sits the vehicle itself. It is a 1-ton sled, hand-laid with 28 layers of carbon fiber and packed with heavy neodymium magnets. It has absolutely zero moving parts. Pushing that sled requires a 50-megawatt power surge. 800 supercapacitors store up energy overnight, only to be completely discharged in exactly 5 seconds. That extreme burst of electricity acts like a fighter jet catapult. It punches through the vacuum, launching the sled from a standstill to 600 kilometers per hour in less than 3 seconds. A person completely blacks out at 5 Gs of acceleration. This launch sequence subjects the sled to an unsurvivable 25 Gs. The design of the chassis reflects this lack of human utility. The carbon fiber shell lacks any life support pressurization, and there are exactly 0 windows. The crushing G-forces and total biological hostility prove this multi-billion-dollar project was never designed for public transit. The chief engineer on the project publicly admitted its true function. The entire track is a massive linear motor, engineered to operate as a ground-based aircraft carrier. This schematic illustrates the mechanical intent. Instead of a passenger car, the magnetic rail locks onto military drones, heavy fighter jets, and aerospace rockets, slingshotting them horizontally until they reach extreme speeds and decouple. By letting a magnetic wave do the heavy lifting along the ground, a rocket bypasses the need to burn tons of heavy traditional liquid propellant during the initial launch phase. A commercial intercity line based on this technology is currently breaking ground, but the engineering philosophy has a massive hurdle to clear. Before any passenger steps inside, engineers must heavily pressurize the cabins and entirely rewrite the launch profile to lower the G-forces. Right now, every single extreme component in this high-speed system is domestically engineered. There is no imported technology anywhere on the track. By mastering these extreme, infinitely repeatable physics, China has moved completely beyond train design to engineer the electromagnetic future of aerospace.